Hello, I am Ritu Goyal and my topic for final project is Big Data Case Study in Marketing. I have selected an auto insurance company for Big Data Marketing Case Study. Traditionally, insurance companies relied on small number of variables as data for potential customers. Today, with the sophistication of data modeling, large amount of different data can be analyzed to help them understand their customer behaviors. The dataset I'm using has customer lifetime value, and this data is being used as target. What is customer lifetime value? It is the amount of net profit predicted from a customer over the entire life of relationship. So it considers current and future income from the customer, and it subtracts the expenses and losses. So it is important for insurance companies to understand which customers are predicted to bring higher customer lifetime value. And big data analytics makes it possible by analyzing huge amount of data. So what is the problem or the question? Marketing department of this insurance company wants to understand which demographics will lead to better customer lifetime value. Using this data, targeted marketing campaigns can be launched. So the technology that I will be using is Spark on Hadoop and Spark MLlib decision tree regression modeling to predict this value. So what is Hadoop and what is Spark? Hadoop is a free Java-based programming framework that supports the processing of large data sets in a distributed computing environment. And Spark basically extends MapReduce model to efficiently support more types of computations, including interactive queries and stream processing. As you can see in the process flow here, Hadoop reads and writes on disk during MapReduce operations, while Spark performs in-memory data processing. This in-memory processing is a faster process as there is no time spent in moving the data process in and out of the disk. Spark integrates closely with other big data tools. It can run on Hadoop clusters and access any Hadoop data source, including Cassandra. MLlib is Spark's machine learning library. It makes data modeling scalable and easy to use. So let's see the steps for this process. Step 1 is to clean the data and prepare input file. Based on the 3 parts to the problem question, I created 3 different decision tree models. So let's see the first one as an example, and the other 2 are pretty much same kind of process. In this example, state and location is used as categorical feature and customer lifetime value as the target. Step 2 is to write decision tree modeling program. Decision tree builds regression or classification models. It breaks down a data set into smaller and smaller subsets, while at the same time an associated decision tree is incrementally developed. So first, state and location are treated as categorical features and converted to numbers. Then they are converted to vectors. Customer lifetime value is used as target. Decision tree regression model gives true versus predicted output. The decision tree model predicts customer lifetime value based on demographic features. Predicted values can be saved as an output file. This is how the output of a decision tree looks like. A folder is created with files. Part 00000 contains true versus predicted values. In order to prepare data for visualization, I created an Excel file, added state and location from original data, and predicted CLV from modeling output. State and location was then concatenated, and the file was sorted by predicted CLV. Step 5 is to visualize data for interpreting output. D3 will read output file and create D3 visualization that can be rendered on any modern browsers. X-axis will use ordinal scale to create categories. Y-axis will read CLV and will have linear scale. A line chart is created based on X and Y values read from the CSV. Let's look at the line chart produced by D3. Urban residents of Arizona seem to have the highest predicted CLV, and marketing department can use this information to develop their marketing plan. Next is urban folks in Nevada, and rural people in Arizona will bring the least CLV. When looking at the gender and marital status analysis result, it is clear that divorced females will bring the greatest CLV in future, while single males will bring the least. In this last visualization, doctors making greater than $20,000 but less than $40,000 are being predicted to give larger CLV, while doctors making greater than $80,000 will bring the least CLV. So before I created decision tree model, I created linear model, but in comparison, decision tree modeling produced better results. Also, what I tried was combining all the demographic features together against the target value, but the result would not have been helpful to the marketing department. Here is the data that I'm working with. You can see the demographics and customer lifetime value. This data has about 9,000 records. So this is my decision tree code. This is path to my input file. This code converts feature, state, and location to numbers. Code here converts features to vectors, and then they are concatenated together. Next, I'm setting up data and then creating a decision tree. And in the end, I am saving the output in a file. To run the decision tree Python program, I used Spark submit command. It starts the map reduce job. So it's running the map reduce job. You can see decision tree nodes, and the predicted values were shown, and here is the performance index for the decision tree, and in the end it's going to just finish running and save the file as an output file. So now I just want to see the output file. I can see it created this folder. Opening the folder. These are the files it generated within the folder, and then I basically will copy the file. So this is my HTML code for D3. At the top is cascading style sheet, and then we move down. Ordinal scale is used for x-axis for categories. For y-axis I use the linear scale. Line chart is being created here. Here it's reading data from the CSV file, x-axis data and then y-axis data. Python server needs to run for D3 to read dynamically. So this is what I'm doing here. I'm starting the Python server on my machine. Then I will go to the browser and type this URL, and the line chart is being created. In summary, big data analytics can be used to answer marketing questions. This case study was able to predict customer lifetime value based on demographics. Spark MLlib decision tree regression modeling was used, and D3 was used to produce visualization of the data, and line chart made it easy to interpret the results. Hope you enjoyed watching my video. Thank you. Bye.